So here's the next set of parts I'm gonna machine. We got the bottom plate, and then we have the top plate, and then these are the two pieces of material that I'm gonna use for that. 4 inches diameter and 4 inches long. So let's get down to it and start making some chips. Look at that big beefy chip here. It's still attached. If I pull my finger on it, it will cut it straight. So the outside turning is done. This face turning is done. Put a chamfer here. And then this is the end of the tapered hole. It's supposed to be 31.1 in millimeters. So you can see it's pretty much around 31. It's hard to measure this edge. And then the inside diameter here, where the slug is gonna sit, that inside diameter here is 22.5, so that is also done. Here's a piece of rod stock that will be forged. So you can see it goes right in. It's got a little wiggle room. This will be heated up to red hot and then dropped in, and the top is going to be flush when I cut this to size. This is just pure saw cut at this time, but I'm gonna face the end and there will be a pocket machined, and then this end is going to be heated up and then dropped in. You can see it fits nicely. Here's the next piece in the puzzle that I'm gonna machine. This is the upper piece of the tool. Again, the drawing is not up to date. I will do some changes to it, but it involves turning and then boring the hole, and then it's gonna have a square cut right there where the plunger is gonna come through. And I'm gonna use this piece of 4140. It's about 4 inches in diameter and 4 inches long. So let's go make some chips. Well, done with the finishing pass. So let's see how it fits. Wow, that's a good fit. I blew out the chips and it looks like my compressed air has a lot of moisture in it. You can see it's doing a vapor lock. I marked the depth where the hole should be, and beautiful. That's a good fit. Here's what we got so far. I did not file the corners yet. I just went in with a 1/8 end mill. Let's do a fit up test. That's about 80 microns of clearance. I was shooting for 25, but I take 80. Doesn't really have the pop sound, but that's good. So this is going to be the top part that sits at the top of the plunger, like so. And I need to bolt these together, these two, because that is gonna retain the spring. So if it's not bolted together, the spring's not gonna be able to pull the plunger back from the workpiece. I put 3 holes here, 3/8/16. I got the fasteners. And the problem is that I really don't have a dividing head. I need to go in like so and drill and tap a hole and then set it, 120 degrees and so on. Now I can do 4 holes, but I really want to do 3. Nothing ever works except when it does. Managed to cut that first time. Kinda cool. Some of these videos are 20 minutes in length, but they can encompass, weeks of work. When you see one thing being done, that could be last week, and that's just how it is. It's a home machine shop. Time not always linear. Well, as you can see, this top piece is done, and when you look at the print, all the print says, drill 3 holes, just like that. It says 3/8/16, National Course Thread, 2B tap, 19-1 depth, 5/16 drill is the core drill, drill to 23/8. It says 3 holes. It doesn't say anything else, but there's a lot to it. First of all, when you drill these holes, they will break through on the inside,
and they're going to cause burrs. So you got to go in and remove the burrs, grind them out. And then the next thing is, I still don't have a dividing head, so I just use this as a template to drill these holes. You can see these are just shallow holes. The idea is that the bolts will go and engage them and provide some stability. So this one goes in like so. Tighten up the bolts, and it will lock it in for good. It's not moving. So that part is done. Now I need to go and dress these edges. I have not done that yet. So the next thing is just to remove the sharp edges here and then add the small radius. Eventually that radius is going to become an internal radius inside the workpiece, and it will probably not copy the radius exactly. It will become something what we call in the industry free material flow. When this part is going to plunge into the workpiece and it's going to forge that pocket and displace material, it will maintain the grains of the material. It will not cut through the grains. So the material essentially is going to flow around that radius. We'll see how that works.